right, Algebra 1B students. Welcome to part 1 of your video on lesson 12.7. Kind of shift gears a little bit today and begin talking about probabilities, theoretical probabilities in this case. Now, in order to talk about probabilities, we have to get some basic vocabulary understood, okay? An outcome for a certain process is the result of a single trial, like spinning a wheel or flipping a coin or rolling a dice. What happens is called the outcome of that particular situation. When we have something like rolling a dice or flipping a coin, we have a sample space which is just a list of all possible outcomes. So for example, if you roll a dice, your sample space would be 1, 2, 3, 4, 5, 6. Those are the 6 outcomes you could get when you roll the dice. There's nothing else that could happen besides those 6 things. Okay. An event is any outcome or group of outcomes that you are interested in. Okay. The outcomes that match a given event are called favorable outcomes. So just as an example, if our event is rolling a dice and getting an even number, rolling a dice, as I mentioned, has this as its sample space, right? Six outcomes, 1, 2, 3, 4, 5, 6. The favorable ones, if our event is rolling an even number, would be, well, the even numbers, 2, 4, and 6. So these are my favorable outcomes. All right. Now, the probability of a certain event, probability, tells you how likely it is that that event will occur. In this video, we're going to find probabilities by reasoning mathematically. Later on in other videos, we will use data collected from an experiment to do that. Okay. Now, in the dice example here, if we're talking about the probability of this event, probability of the P of the event, probability of rolling an even number, which we usually would write capital P even, probability of getting an even number, is equal to the number of favorable outcomes there are, which in this case 1, 2, 3 favorable outcomes, out of or divided by the total number of outcomes, 6. That's the probability. 3 over 6 is a fraction, which we could obviously reduce pretty easily down to 1/2. Okay. So, as I mentioned, the theoretical probability, which is what we're focusing on today, probability of that event happening theoretically is the number of favorable outcomes in the space over the total number of possible outcomes. So as I mentioned, probability of rolling an even number, 1/2. Right? You can write the probability of an event as a fraction, a decimal, or a percent, but it must always go between 0 and 1. Sorry, it must always be between 0 and 1. Never allowed to be bigger than 1, never allowed to be smaller than 0. All right? Now, here's just a quick example word problem to sum this up for you. It says our solar system's 8 planets, in order of least to greatest, from the Sun, are Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. If you randomly draw the name of one of the planets, what is the theoretical probability you will select a planet whose distance from the Sun is less than Earth's? Well, Earth is here. Which ones are further from the Sun? That'd be all these. Which ones are closer to the Sun? That'd be these two. So this is my sample space, right? Sample space is here. So the probability of getting a planet that is closer to the Sun, P of closer to the Sun, probability of closer, is the number of outcomes that would give me one that's closer. That's 2 planets out of a total of 8, all right? Which reduces pretty easily down to 1/4. So this is your theoretical probability. If you have questions about theoretical probability or how to find it based on a sample space and outcomes, please make a note to ask me in class tomorrow. Otherwise, that's all I have for you. Have a wonderful night.